If you were outside today like I was, playing golf around, I don't know, 2 o'clock, you probably had a nice day, except that around 3:30, it got super cold to the point where I've never seen this before. People on the golf course were leaving. They gave up playing golf because it was so cold. There was this, I don't know, wind, Arctic chill. I don't know where it came from. It just froze everybody. People were all in shorts, short sleeves, and they were all scrambling to get out because it got super cold. It was one of those weirdest things. I don't even know how to explain it. Anyways, it wasn't that much of a great day after all, weather-wise. Well, anyways, let me start this. So, is it possible for a triangle to have sides with given size? So, if you have, imagine you had one stick that measures 19, another that measures 13, and another measure that's 14, right? Make the 14 a little bigger. Would these three, let's say this was a 19, and I had something that was 13 over here, and something that was 14 over here. If these went this way, close. Imagine these closing as the arm went to the this 13 here went this way and the 14. Would they close? Right? Would they touch here to make a triangle or not? So that's what you're being asked. And one way to do that is to see if the sum of any two sides is greater than the third one, and that's what we talk about on Friday or Thursday, depending on your class. So here we have three sides. So all you gotta do is pick these two, and see if it's greater than the other one. And then you repeat the process with the different pairs. So 19 and 13 we did. We'll do 13 plus 14 and see if it's greater than 19. And the other one would be 19 plus 13 and see if it's greater than 14. So we have to do this 3 times, right? And pick the 3 different pairs, 3 different combinations that we make. Well, obviously 19 plus 13 is 32, and that's greater than 14, so this is good. 13 and 14 is 27. It's greater than 19. This is also good. And this is 32. Sorry, I made a mistake here. This should be 19 plus 14. And it should be greater than 13. And notice that they all say that the sum of the two sides is greater than the other third side. So in this case, because it was true for all 3 inequalities, these 3 sides make it's possible to make a triangle out of this one. Possible to make a triangle with these side measurements. Remember, it has to be all 3. Okay, all 3 have to be true. If only 2 of them are true and the last one is not, then you can't make a triangle with those 3 side measurements. Well, let's see this one. Well, this one's interesting because they're all the same. So we have 9 plus 9 greater than 9. And then if you were to do that 3 times, right? I mean, I know you don't have to, but we have 18 is greater than 9, and 18 is greater than 9, and 18 is greater than 9. So again, yes, yes, and yes. So with 3, a triangle with the same side length, 9 centimeter, 9 centimeter, 9 centimeter, you would be able to make a triangle. Okay, so that was the triangle inequality theorem that we taught. 3. Which of these could be the size of a triangle? Well, let's see. For this one, I'll show you. So let's take 15 plus 7. Right? So if you take any 2 sides, it has to be greater than the third one. So we start with these 2. We get 15 plus 17, which is 22. And it's not greater than 23. So we don't even have to do the other 2 pairs. This is already a no. So this does not represent the side lengths of a triangle. Let's try this one. Well, if you pick 5 and 9, is that greater than 13? And 5 and 9 is 14. And again, that is. So far, so good. Let's do 5 and 13. Is that greater than 9? Yes, it is. And then let's do the other one, which is 13 plus 9. Is that greater than 5? Yes, it is. So it's a yes, it's a yes, a yes. So if you pick any two sides, is it greater than the third side? It was for all three possibilities. So this makes the sides of a triangle. Let's do C and D, even though we already know that B is the answer. So look at C, for example. Once you pick one and you find out that it's a no, then you don't have to do the other one. So let's pick these two. 8 plus 5, is that greater than 13? 8 and 5 is 13. Is that greater than 13? No, it's not. So I don't have to do the other ones. And because I already got a no, I know that this does not form the side of the triangle. So this one, 6 and 15. Is that greater than 23? 6 and 15 is 21. And it's not greater than 13. So again, you don't have to do the other two pairs. And because we know that this is not already represents the side measurements of a triangle. So this is also a 4, same question. So let's do A. And A, let's start with 10 and 7. So let's do 10 plus 7. Is that greater than 16? Well, it's not, because 17 is not greater than 16. So no, and I can stop right here. And I already know that A, it's not. Let's do C. 14 plus 4, is that greater than 19? Yes, it is. Because, 14 plus 4 is 18. Is that greater than 18? No, it's not. So again, I can stop here. And I already know that C does not represent the side lengths of a triangle. Let's do B. 6 and 10. 6 plus 10. Is that greater than 16? You'll get 16, which is obviously not greater than 16. So also a no, right? So notice that I don't have to do the other two pairs, right? So I can stop right there, and I know that B is not correct, which leaves me with D. Well, let's do D. 3 and 14. Let's take these two sides. Is it greater than 19? Hang on a second. Did I mess up here? Okay, so I messed up. And I messed up on A, right? Obviously. So I can't add. Let me go back to A. Let me redo this. So if I get 10 and 7, is that greater than 16? Yes, it is, because 17 is greater than 16. So we have a yes. So because I have a yes, I'm going to continue and do the other two pairs. So now I'm going to try 10 and 16. Is that greater than 7? Obviously it is. So that's a yes. Then let me pick the other two. The other pair would be 16 plus 7. Is that greater than 10? Yes, it is, because 23 is greater than 10. So yes. So with A, if you picked any two sides, 10 and 7, or 10 and 16, or 16 and 7, is it greater than the third side? Yes, yes, and yes. So A is the correct one. So A is good, and then C was, we already said that it was not. B was already, we already said it was not. Let's try D, and I'll start with 3 and 14. Is 3 plus 14 greater than 19? 3 plus 14 is 17. Is that greater than 19? No. So therefore, I can stop right here. I don't have to do the other pairs. And let me show you the other pairs. Would be 14 plus 19. Is it greater than 3? And then 19 plus 3. Is it greater than 14? So if you look at the other two pairs, here you have 33. It's greater than 3. That's a yes. This one's 19 and 3, which is 22. Is it greater than 14? It's a yes. But like I said, we need 3 yeses, and we have 1 no here. This was a yes. This was a yes. But with this particular two pairs, the two here, the two sides, 3 and 14, it was not greater than 19. So this does not represent the side length of a triangle. So A was the correct one. So 5 says the side measures of two triangles are 11, 15. So you have 11. Something that measures 11 and something that measures 15. And I don't know, I'll just make it like this. Let me lower that. Something that measures 11 and something that measures 15. Right, so I can have, and I'll put it in blue, I can make a triangle, and this could be one the length, right? Let me try another one. I can put 11, I can put 11, and I can make the 15 go this way. Right, 11. And we can make a triangle using this blue one, whatever the measure it is. Let me do another one. I can make 11 like this. I can make 15 go this way. And then you would say, I can make a triangle. I can just get this guy here, right? So notice that with sides 11 and 15, I can make different types of triangles, measuring different lengths, right? This blue, which is represented by the blue line, so it could be something that measures that measures this much, or something that measures very little like this. So the question here says, what can these measurements be? What's the range of all the third sides that we can do? So I'm going to do this the long way. So the first thing we can do is something like this. We can have one side is 11, one side is 15, and the other side is called x, right? Because we don't know what it is right now. Well, remember what we said before? Any pair, any two sides, the sum of any two sides have to be greater than the third side. So let's do that. So 11 plus 15 has to be greater than x. Let me pick another pair. Let's do 11 and x this time. So 11 plus x has to be greater than 15. And the last one is 15 plus x, and that has to be greater than 11. So those are the three different pairs that I can make. So let's solve these inequalities. 11 plus 15 is 26, which is greater than x. This is minus 11 here, minus 11 here, so x has to be greater than 4. This one is minus 15, and x has to be greater than negative 4. Now, I mentioned this in class. I am not particularly keen with this inequality being written this way. I like it written where the variable is on the left side. In order to do that, I can switch sides, but if I switch sides, I gotta switch the inequality sign. Now, how do I combine these three to represent the range for all x values? So here, I'm going to create a number line. So at the bottom here, I create a number line. And I'm going to go negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 20, and then let's pretend 26 is over here. So let me draw the solution for the first one. So this says as long as your last side, right? So if you have 11 as one side, 15 as the second side, the last side here says it has to be less than 26. So less than 26 is represented by that, right? But notice that it doesn't make sense because if I pick negative 4, for example, can negative 4 be the third side? Can the third side be negative 4? That doesn't make sense, right? Because our side with the measurements can't be negative. So keep that in mind for now. So that's my first inequality. The second inequality, let me graph that. Second inequality says x has to be greater than 4. So right here on top of 4, not including 4. So that says that as long as your triangle has any side measurement that is greater than 4, it will work. And the last one says x has to be greater than negative 4. So I'll put a circle over here, open circle, because negative 4 is not part of the solution. But it says that your triangle, as long as it has the third side that measures any number above negative 4, will be okay. But again, can negative 3, can negative 3.99 be the third side? Well, those negative numbers can't represent this third side. Neither can 0. So what we need to do is find a common ground between the three solutions. The common ground between the three solutions is this area right here. Everybody has this area right here as part of their solution. So that's going to be my answer. And how do I write that? Well, so that says that x, this third side, can be anywhere between 26 and 4, but it can't be 26. So under 26 and greater than 4. And the way you write this is this way. X has to be greater than 26 and greater than 4. Less than 26 and greater than 4. So the range for all the possible sides of that third side there is between 4 and 26. That's the long way, and I don't think anybody wants to do that. So the shortcut is, what you noticed, shortcut is to find the range, you need to do one very simple thing. On the low side, you're going to take 11 and 15, and you're going to subtract, right? You're going to obviously subtract 15 minus 11, right? And that's what you're going to put here. And then on the higher side of your range, the max side of your range, you're going to add these two values, 11 and 15. So 15 plus 11. And if you do that, it'll tell you that you can go as far as 4, but not including 4. And on the high side, you can go as far as 26, but not include 26. So your x, that third side, so if I gave you two sticks, one that measures 11, the other one that measures 15, the other stick to create a triangle can be any number between 4 and 26, and that's your answer. Okay. 6. All right, so again, same question. So let's take the shortcut. So to find the range, right, x can be a number between these two values. On the low side, you're going to subtract these two. On the high side, you're going to add them. So on the low side, this third side can be 13 minus 12 is 1. And on the high side, 13 plus 12 is 25. So our third side, so if I gave you a stick that measures 12 and the other one that measures 13, this last one here can be the length of the third side can be any measurement between 1 and 25, not inclusive. Okay. Yeah, that's it. 7 and 9, 8 is the same question, same exact question, except it's not multiple choice. So was 6 a multiple choice? Yeah, 6 was a multiple choice. 6 was a multiple choice, and the answer was this one, B. Okay. So 7 and 8 are not multiple choice questions, right? But again, same exact thing. So x, we want a value for the third side. We know that one of the sides measure 8, the other one measure 10. So the third side can be anything between the difference of 10 and 8 and the sum of 10 and 8. So it could be 2, not 2, sorry. We're above 2 and under 18. Number 8, same thing. This third side can be, the lowest it can go is the difference between 15 and 9. And the highest that it can go is the sum between 15 and 9, not inclusive. So 15 and 9 is 6. 15 plus 9 is 24. So any number between 6 and 24, not including 6 and not including 24, could be used to make a triangle if you had one stick that measured 9 and the other one that measures 15. So it could be I don't know, it could be 6.1, it could be 23.9, it could be 8, it could be 8, it could be 10, etc. So that third side could be any number in between these two values, 6 and 24. 9. So 9 says, hey, regardless of if you were given two sides of a triangle, just imagine two sides, right? Is there what's a generalization that we can make to find the sides, to find the sides of the side lengths of the third side? So no matter what I give you, if you have two of the sides, what are you going to do? Well, if you have one side that's called A and the other one is called B, and the last one is what can X be? Well, X can be any number that's going to be between the sum of A and B and the difference between B and A, where B is greater than A, right? The difference between these two numbers, so let's say you had 12 and 8, you would do 12 minus 8, and then on the high side, it'd be 12 plus 8. And so this is what you have to remember, right? So if you're given two sides of a triangle and you want to find all the possible values, the range for all the possible values that represents third side, you're going to just subtract the 2 to find the minimum value and add those two to find the maximum value. But make sure that if they're, that you can't include those two values. Okay, so in this example here, it'd be between 4 and 20, not including 4 and not including 20. Last one, it says Elma wants to go to Miller's Peak, but she needs to go to Sutter Spring to get water, and then we'll hike Miller's Peak from there. Will she have to hike farther than 6 miles? Well, If she didn't have to get water, she would go from here to here, and she would travel 6 miles. Agreed? But we know this forms a triangle, first of all, right? She's not doing that trek. She's going actually to Sutter Spring first, get some water, and then she's going to go to Middle Creek. So what do we know about the sum of these two parts here, the greens? Well, we know that the sum of those, now call this x and y. Right, so the sum of x and y, which is the trek that she's doing, is going to be greater than 6. How do I know that? It's because it's a triangle. And if it's a triangle, we know that the two sides, any two sides in this case, when we're talking about x and y, this side here and this side here, will be greater than 6, right? The sum of any two sides in a triangle will be greater than the third one. That's it. I know that was really simple. Some of you did this in class.